So we have confirmed that the curve can take on such a shape. This as 1, as we're integrating from x is 1 up to x is 2. So the strip is drawn about the x-axis, which is changing x. So if you want to find the area, it would be the integral from x is 1 up to x is 2. V of x, x, giving us the integral from 1 up to 2 over 4x minus x squared is integrated with respect to x. So this area becomes 4x squared over 2 minus x cubed over 3 from 1 up to 2. Since substitutions begin with the upper limit, we can now have, I can reduce this 2 by the 4 to give us 2, which is 2 of 2 squared minus 8 out of 3 minus 2 minus a third. This gives us 8 minus 8 out of 3 minus 2 plus a third. This gives me 6 minus 7 out of 3, confirming 18 minus 7, which is 11 out of 3 square units. So 11 out of 3 confirms 3 and a third. No, sorry, 3 and 2 over 3, 2 and 2/3. So 3 and 2/3 is the area. But what I wanted out of this question is that you find that this question had this increment, which was a little bit technical. So that increment can be investigated by checking the intercepts. Hello, Mbabas, are you there? Teacher, your network is not clear. My network was fine, though someone made a call and came through, which challenged me. I wanted to give you one more illustration. Find the area bounded by the curve. Sorry, this is a line between x is 2 and x is 5. So to start with, one needs to know, how does the line look like? You'll find that when x is 0, y is positive 4. Whereas when y is 0, x is also 4. So ideally the curve looks like this. Now they want us to find the area between x is 2 and x is 6. Now these two areas, as you look at them, they are the same because the difference from 2 to 4 is the same as the difference from 4 to 6. But this curve down here is a negative. Then this one up here, this area is a positive. So one has to be very sensitive when interpreting the question. That's why you need to sketch. So when you sketch, you see that this is a positive, while this one will be what? Negative. And remember, I told you if you want to find the area, you can get the area from integral of a function in terms of x, dx, like from 2 up to 4, plus.
Teacher, is 5 or 6?
It's supposed to be 6. Then from 4 up to 6. But because this area is negative, I can attach a negative down this way in front of the integral notation of the same function with respect to dx. So the area would become integral from 2 to 4 of 4 minus x dx plus the integral negative from 4 up to 6 of 4 minus x dx. Now, because this is a line, when you integrate, you attain 4x minus x squared from 2 up to 4. Then minus 4x minus x squared from 4 up to 6. When you make the substitution, we shall realize 16 minus 16 minus 8 minus 4 minus 4 times 6 is 24 minus 36 minus 16 minus 16. So this gives us 0. Also, this gives us 0. So this will attain negative 4. 24 minus 36 is a negative 12. Negative 12, there is a negative out, confirms the positivity of 12. So finally, the answer becomes a positive of 8 square units. Whereby if you do not go by that and introduce the definition of a negative right there earlier, you're going to get a negative 8 square units. So it is upon you to interpret that and say, because area can't be a negative, area is a scalar. Then you have to take the magnitude of that scalar and confirm that it is a positive 8 square units. But if you put the negative from the word go on that area below the x-axis, then the result will come out as a positive. Why we had to add those two areas is because the area being talked about, being contested in the question, was covering from here and also inclusive of these triangles up to there. Another way one could have handled this solution is by saying, because both of them have a limit integral of 2, you're integrating from 2 to 4, there's a difference of 2. You're integrating from 4 to 6, there's a difference of 2. It would imply that it's the same as saying its area is equal to the integral twice the integral of -1. So for example, Okay, the integral of twice from f of x dx from 0 up to 2, which would give us, no, this one to work on this category. You can leave it at that, so that we can always have these interpretations done as I've handled them. Some people have failed to come back when you had a network interruption, but I will see if I can arrange for them a small video to share with them. Unless if someone has a question, otherwise we have around 3 minutes to conclude.
When we were integrating for this number we've just done, why didn't we add C there?
Sorry for that. When we are integrating, why did we add the C? Are you asking why we didn't add the C?
Yes.
Hey, I said with integration, we integrate with time. A period can come because we know that if I put a C here and a C there, this C will be here as plus C minus the C which would have come from this side. So the C's will always cancel. So whenever we have a definite integral, you can minimize the C's, and because at the time at one point they will have to be erased as a result of subtraction. So to avoid over repeating ourselves by writing the C, we can neglect it from the word group.
When integrating for all these curves, can we also integrate like the way we integrate when finding area under a curve for the cumulative distribution functions, or we have to integrate just this way?
For the cumulative distribution functions, the idea is the same, because still also then you're finding area under that curve. Yeah, but that area is in terms of probability. The distribution you have is a probability function, whereby it cannot give you a whole number, it will give you a decimal at any one point. Also, that knowledge will come back in what we call trapezium rule. Trapezium rule is a technique for finding the area without using integration under a curve. For which it will be showing you a different technique of summations or accumulations of strips, which strips require what you call the trapezium rule. Now, for the probability distribution, you'll find that the distribution will always be defining a probability distribution, no matter the size, no matter the quantity of the limits you have. Okay, so it's exactly 11:59. So let's use that last minute, prepare for the next lesson. Any further questions, reach me on my WhatsApp line, if you have WhatsApp, or you can go to my Facebook account. My names are the ones I use, and raise any concerns. Okay, we have a good day. Oh, before good day, someone says we need to be added on the WhatsApp group. My number is 0782 855 674. That is my WhatsApp number. So you send me a WhatsApp message on that. Hope you've captured that.